Hello everyone, I want to introduce the SPSS algorithms in Spark, the random trees algorithm today. And I will first introduce what the random trees and the advantage of the random trees. And then I will show user cases about how to use the random trees in Modeler. And then finally, I will give a demo to use the random trees in Jupyter Notebook from the DSX platforms. So what's the random trees? Actually, in other products, they call the random forest. And in SPSS products, we call the random trees. It's something for copyright or legal reason. And the below is the introduce for the random forest that from the wiki. It's very long. I will read. Random forest or random decision forest is an ensemble learning method for classification, regression, and other tasks that operate by constructing a multitude of the decision trees at training time, outputting the class that is the mode of the classes for classification, mean prediction for regression of the individual trees. It's a little complex, but we can use some keywords to learn about this. And first, it's combined by the decision trees. That means it's a lot of trees. And the second, it's an ensemble method. And the third, it supports both classification and regression. And the fourth, is predicted by the vote or average. Vote for classification, average for regression. It's also a well-known and popular algorithm in data mining. We can get almost all the popular statistics tools include the random forest algorithm. For copyright reason, SPSS random trees named random forest named random trees. So what's a random trees? And before I introduce the random trees, I want to introduce the tree. We both know like the organization chart in the left and the right directory trees boast tree structures for the tree chart. And it's how the root, it has the nodes, how the leaves, and how the branches. It's the common attribute for the structures. We call the structure like this as a tree. But in data mining, we introduce another type of the tree. We call the decision tree. So what's the decision tree? And for example, you want to plan a journey, and you care about the time. If you care about time, and you need to know the distance of the journey. And if it less than 1,000 kilometer, and I think you should take the high-speed train. If it more than 1,000 kilometers, the better way you need to take airplane. If you want freedom and you want to stop anywhere, and you'd better drive a car, drive by yourself. And if you want the sensory, you can take a normal daytime trains to enjoy your journey. That is the decision tree. We can say that the decision tree we have the conditions. If we choose the conditions, we can follow the branches and the conditions to the final decisions. The decision tree help us to make the decision. It is a very common data mining methods. Then we introduce the decision forest. If we have many decision trees and they work together for the same tasks and they predict by vote or mean, and we can call it decision forest. It's many trees combined together. So we start to introduce the random trees, random forest. We have already introduced the forest is combined by the many trees, and then the random forest is we use some random method to build many decision trees combined together for the same work. The random forest have two dimensions. The first dimension is data. It uses different data in each tree. We have many trees, and each tree uses different data, and the data maybe have overlap. We can take a look. For the first tree, as example, it random select 4 cases for model building for learning, and the second tree, and it take random select 5 cases, and it has 1 case or some cases same with the tree 1. For the tree 3, and it has 6 cases selected. It both have overlap with the tree 1 and the tree 2. That is the first random dimension, and we can second. And we take the second dimension is that the random variable selected for the each node in the same tree. We take tree 1 as an example. If we build a tree 1, the first node, we select 5 variables here. We not use all of the variables. We just select the 5. The 5 variables to select as a candidate to learn the node 1, and then we want to grow node 2 and node 3, and node 2 we have random select also random select 5 variables. It maybe have something that have some variables same with node 1, maybe not, and further, and then grow the node 3. Node 3 also random select some variables, not all the variables, and it may be have same with node 1, with node 2, or not same. That is the random, the 2-dimension randomness in the random tree. So after we use that, we will build a lot of trees and use different records, and in the same tree we use different variables, and we call this method to build the decision trees is random trees, random forest. The advantage of the random forest, first, I will give some some of the advantage. It's not all. First, it is embedded variable importance, and we grow trees, and we have samples, we have testings, and we can compute the variable importance in the random forest. We do not need other method, other algorithms introduced to compute the variable importance. And then the internal unbiased estimate, because we use the random, we not use we not use the same data, we not use the full data. We have random samples, random variables, random cases, and we can handle the unbiased data. We can handle the imbalanced data. If we use the sample, in sample cases, we do the sample use some imbalanced sample methods. We can handle imbalanced data, and then in SPSS random trees, we can export interesting rules, decision rules. Since we have lots of trees, we have forest, and so we have lots of rules, but it's not understood by the human, just understood by the computer. We can select some interesting decision rules to user and show some key properties, some key rules for user to understand the whole model. And it can run efficiently on large database. Because of this, use sample data. Any tree has sample data, not all the data, so it can handle the very large data, and it also can handle wide data, and without a variable deletion. Since we have another dimension for the variable to do the samples, so we can handle the wide data. And we also can get good accuracy because of random trees is an ensemble method. Compared with the single model, normally the ensemble model maybe get the better accuracy. I will introduce user cases that use modeler in modeler to use random trees. A telecom company want to know which customer will choose, so that they can take some actions to retain the customer. We have the data like below. The last columns is means tuned or not. The 0 means not. The 1 means already tuned. And we have the data. Firstly, since we have data and we want we use the last year's data as a training and use the February data of this year as a testing to check our model accuracy. Since it's true or not, it's a binary issues. So we want to use the logistic model to try. So we use the data and we select logistic model, and we analyze the result, but finally we get the output. The accuracy is only about 10%. It's not good. Actually, it's very bad. And then we can try decision tree. We use the cart classification and regression tree, and then maybe we can use the boosting and to get the better accuracy. So we get the result when you use the single tree. and we got about 7-8%, and we get we use the boosting. We use boosting. We get more, get better result about 80. Seems better, but not enough. Maybe we can try others. So we tried the random forest. We tried random forest. We use the same. We can use the random forest, and we get the result. The result. We get the result. The accuracy about over the 90. It's much better than others. So it's because of random trace generates many trees with random samples data, and for each tree node split with random variable selected. It's randomness. Randomness importance. Because we split the testing and the train and the training, and we can get the accuracy, the better accuracy. From this user case, we can find a random trace advantage. That's better accuracy. Okay, then we go to another diamond. As we try DSX. Okay, that's the IBM data science experience cloud environment, and we use the same cases the before same user cases before, and we want I will introduce how to use it in the data in the DSX. First, we prepare the data, and I already showed that I already upload the data to the to a common website. The last year's and this year February data for testing, last year for training, and then we prepare the data. We use some we can read the data to a data frame and use the Spark, and we show the schemas. Yes, and testing data to data frames. We use SPSS tools to set the to configure the variables. We set the ordinal variables for the education. It's ordinal, and some nominal variables here, and others not set as continuous, as numeric. We use set nominal measure, set ordinal measure. This both came from the SPSS utils. And then we fit the data, use the training data side. We got the model. After we got model, we can do the transformations to do the prediction, and then get the prediction. Use the testing data, we can get the prediction diaphragms, and then we use the evaluator to get the evaluator result. We got the accuracy result. It's 19.4, about 95%. SPSS also has the model viewer components to show the model result. For the random forest, we can get the following results from the model viewer. There are some, if you want to use the model viewer, you need to import the project notebook integration methods, and you project utils, and you need new project contacts, the spark contacts, and this is the project ID, and this is your this is also your credit ID. You come from other paths from the demos setting part. You can get these two values. Its the first result is the model evaluation, and we have some measures about model evaluation. We can get kind of model evaluation, and then model informations, the targets, and methods, and predictors, and model accuracy, and also misclassification rate. And the record information, so we have hundreds records. We have thousands records, and all the records include this. There's no drops. Predictor importance, and here we can see the tenure, age, address, region, the importance. We can see the importance, which predictor more importance in this case. And top decision rules, that's what I said before. And it can show us the very, very interesting rules here. It's easy to understand for human reading. And conflation matrix, we have percent correct matrix, conflation matrix. Finally, if you want to know, say more detail about the model, you can export the XML, export the StatsML and PML, directly import to some files. The product ID that we use the model viewer, you can see here, product ID. This is the credit ID. You can get it from here. Demos, your products, and then settings. And not here, and we maybe my projects. Here. No. Here, access token. You can view. This is the another key. As use the model viewer, I need your tokens. Okay. That's all. That's all today. Thank you.